All right, IM2 classes. Today we're going to be solving quadratics. First, we're going to do it by graphing so we can see what the solutions are on a graph. Then we're going to be doing it by factoring, and we've had a lot of practice with factoring. So, um, not too much new today. First of all, this word here, quadratic. What a quadratic is any equation where it has the highest exponent is 2. All right. So when you think of the word quad, probably think of 4. And so you might think, well, why is it an exponent of 2? Well, because that's squared, right? So when you have your variable squared, it is a quadratic. It can have more than one variable, something like this, but as long as the highest exponent is a 2, it is a quadratic. And so that's what we're going to be solving today in factoring, and we've done a lot of that. First way we are going to solve these is by graphing. I would never recommend solving quadratics by graphing if you do not have a graphing utility. So what you want to do is use Desmos. That's what we'll be doing in class. You just go to desmos.com, use the graphing calculator, and let me bring up Desmos. Wait, hold on. I need to negative 9x plus 8. So let me bring up Desmos. Um, there we go. So over here, you put in the equation. So x squared minus 9x plus 8. And so here is the graph. You can see the solutions to the graph. This is real simple. If you have this graphing utility, all you're looking for is where the graph crosses the x-axis. And so that gives us our solution. So in 1, 0, and 8, 0. So the solutions to a quadratic are also called the zeros. All right. We're looking for where the graph is equal to 0, or the y-coordinate is 0. So it's just where the graph crosses the x-axis. The most common mistake I will see on these is when kids also include the y-axis. It is not the y-axis. It's only included the x-axis, these 2 points here. So the solutions are 1 and 8. Let me bring up our presentation again. There we go. So, next slide should be the graph. So we can see the solutions are 1 and 8. So you guys will be using Desmos. Just put it in there. X is equal to 1 and 8. So quadratics can have 2 solutions. All right. And we talked about that when we were solving using square roots. So here's our next one. You'd put this into Desmos. I'm not going to switch back over. Here's what the graph looks like when we put in the Desmos. This one, it only has one solution because it only touches the x-axis in one spot. So this one, the solution is just 4. All right. So when you're solving the quadratics by graphing, use Desmos or some other graphing utility that you have. Look it up. The reason why I wouldn't solve these by graphing by hand is because to get an accurate graph, you got to solve them anyways by hand. So it's kind of silly to solve by graphing unless you have a graphing calculator or some sort of utility. But that's where the solutions are. The zeros, it's where the graph crosses the x-axis. So here, what we're going to do, we're going to introduce what's called the zero product property, where you have a quadratic in its factored form. So we have our 2 binomial factors. We are going to solve. All this is we're using what's called the zero product property, is you're going to set each of those factors equal to 0 and then solve each one. So on this one, you can subtract 3 from both sides. Plus 3 minus 3 cancels out. And you're left with n is equal to -3. So n can be -3. This one over here, subtract 6. You get plus 6 minus 6 cancels out. So you get n is equal to -6. So those are our 2 solutions, -3, -6. This is stuff you should be able to do in your head, right? Solving these one-step equations can be done in your head. Here, we're going to skip that one. Just here, even though there's a 7 here, we do it the same way. You are going to split the factors, set them each equal to 0, and then solve them individually. So this one over here, I'm going to add 8 to both sides. And you get x is equal to a positive 8. This one over here is two steps. I'm actually going to put in line of separation, keep track of that equal sign. So I'm going to subtract 6 from both sides. Plus 6 minus 6 cancels out. You get 7x is equal to negative 6. Um, and then divide by 7. So times 7 divided by 7 cancels out, and you get x is equal to negative 6/7. And you leave it like that. Don't put it in a calculator. Leave it as a fraction, just like that. And that's going to happen often with these. We're going to have the answers come out to fractions. So to solve using an X factor, or so solving a quadratic by factoring. So here we have a quadratic. We are just going to factor it using our X factors. So draw out your X and then set up this diamond here. So 40 on top, negative 13 on bottom. Factors of 40 that add to negative 13. That is negative 5, negative 8. Since there's nothing in front of the V squared, um, we can go straight. We can use our X factor shortcut and just put the sides of the diamond straight into our factors. So it's going to be V minus 5 and V minus 8 are our factors. So now we have our quadratic in factored form, and we use that zero product property we did on the last couple of problems, where it's going to be V minus 5 is equal to 0 and V minus 8 is equal to 0. Set each factor equal to 0 and then solve each individually. So plus 5 over here. Plus minus 5 plus 5 cancels out. You get V is equal to 5. Over here, you need to add 8. So minus 8 plus 8 cancels out. You get V is equal to 8. And there we go. We're done with that one. So that's it. So just factor like we've been doing, factoring using that X factor. Once you have the factors, set each factor equal to 0 and solve. Let's do one where we can't use the shortcut. So let's skip to 23. So here, remember, since there is a number in front of the m squared, in front of the squared variable, we need to take our first number and last number and multiply those together, and that goes on top. So we're going to multiply. So 7 times negative 8 is negative 56. Remember that invisible math, there's a 1 in front of that m. So there's a 1 that goes on the bottom here. Two numbers that multiply negative 56 add to a positive 1. That's going to be a negative 7, positive 8. Since there's that 7 in front of the m squared, we can't use the X factor shortcut. So I need to split up this plus 1. That's going to be negative 7m plus 8m. And then I'm going to bring down the rest of my quadratic there, 7m squared minus 7 plus 8m minus 8. And I'm going to factor by grouping, do it in this step. So I'm going to group the first two terms together and the last two terms together. The greatest common factor between 7m squared and 7m, I'm going to divide that by 7m. So when I do that, I get 7m here. That's going to be m minus 1. 7m squared divided by 7m is m. 7m divided by 7m is 1. Plus, the greatest common factor on that second one is 8. So 8m divided by 8 is m. 8 divided by 8 is 1. So we have our identical groupings there. So now I'm going to regroup in our factors together. The first grouping is going to be the GCFs grouped together. So 7m plus 8. And then m minus 1, that identical grouping is our second factor, m minus 1. So, and then so now we have our factors. Now we separate out and set each one equal to 0 and solve. So here, gotta subtract 8. So you get 7m is equal to negative 8. That cancels out. And then last step, divide by 7. So times 7 divided by 7 cancels out. Oop, what the heck happened? How do I turn that off? Whatever. We're just gonna let it happen. Um, Figure it out later. So we get m is equal to -8/7. Ran out of space there. And then last one here. Just need to add one to both sides. So you get m is equal to a +1. All right. So that'll do it for us. So remember when you are graphing, the solutions to the graph are where the graphs cross the x-axis. And then to solve by factoring, you factor. Once you have the factors, you set each factor equal to 0 and then solve each of those equations individually. So your quadratics, they can have one solution, but most of them will have two solutions today. And then next time we're going to do a process called completing the square. And we'll see you guys next time.